Okay, so today we're going to be looking at the basic airflow principles. So for air to flow through a circuit from A to B, the pressure A must be greater than B, or the suction at B must be greater than A. Air will flow through the circuit at a rate governed by the difference in pressure between A and B. The quantity, or flow, or volume is calculated with the following formula. The volume equals the velocity times the area, where the volume equals the amount of air that will pass through a circuit in a specific time, normally in something like meters cubed per hour. The velocity is the distance travelled in a specific time, i.e. meters per second, and the area is the cross-sectional area of the duct measured in meters squared. So we also need to consider the air pressure within a duct system. So there are three types of air pressure. There's velocity pressure, static pressure, and total pressure. So velocity pressure is the air flowing at a specific velocity will create a defined pressure called velocity pressure. This is always positive and always in the direction of travel, typically measured in millimeters water gauge. The static pressure is air confined within an enclosure, moving or not. Exerts a pressure called static pressure, i.e. like the air in your car tyre is a static pressure. And the total pressure is sum of both velocity and static pressure. So here we've got a few examples of what that looks like. So in example 1, we've got a sealed duct capped off at both ends, and inside there's a pressure of 50 millimeters water gauge, or 500 pascals. The velocity pressure is 0 because it's sealed and there's no air flowing. The static pressure is 50 millimeters, giving a total pressure of 50 millimeters. In example 2, the air is blowing through the duct system at 20 meters a second. The velocity pressure is 25 millimeters. The static pressure is 50 millimeters, giving a total pressure of 75 millimeters. And in example 3, the air is being sucked through the pipe at the same speed, 20 meters a second, giving a velocity pressure of 25 millimeters, static pressure of minus 50 millimeters, giving a total pressure, adding the two together, of minus 25 millimeters. And in the next section, we can look at how we can apply some of this in a real world. Formulas up here. So if we take this one for example, if you want to work out the velocity, and you've got the velocity pressure, which is 25, square root of that is 5, times by 4 gives you a velocity of 20, which is what we've got here, and vice versa. If you want to work out the velocity pressure, and you know the velocity, it's the velocity divided by 4 squared equals the velocity pressure.